Hi there, welcome to EudretiX, where we make your high school life simple. I'm Aniket, and today we're going to do the second part of medium difficulty questions for nonlinear equations in one variable and linear system of equations in two variables. So I hope you've already watched part one and practiced with that. So make sure to pause after each question, try it out yourself, and then only look at our solutions. Let's begin. Blood volume Vb in a human can be determined using the equation Vb is equal to Vp over 1 minus H, where Vp is the plasma volume and H is the hematocrit, the fraction of blood volume, that is red blood cells. Which of the following correctly expresses the hematocrit in terms of the blood volume and the plasma volume? Okay, so right now in the given equation, we have Vb in terms of Vp and H. Now they're asking H in terms of Vb and Vp. Okay, so this calls for some rearrangement of this equation. Let's rewrite it. Vb is equal to Vp over 1 minus H. So since the equation was in terms of Vb, so like Vb was represented in terms of Vp and H, so Vb was isolated. Now we need to represent H, so H will be isolated. So first of all, in the sequence of rearrangements, we'll first take H to the numerator. So for that, we'll multiply both sides with a 1 minus H. Now, this and this cancel. So 1 minus H times Vb is equal to Vp. Now we'll start isolating the H on the left hand side. First of all, we'll get rid of the Vb. So divide on both sides with Vb. So Vb over Vb is equal to Vp over Vb. Now cancel the Vb on the left hand side. It's 1 minus H is equal to Vp over Vb. Now we'll get rid of this 1. For that, we'll subtract a 1 on both sides. So 1 and 1 get cancelled. Negative H is equal to Vp over Vb minus 1. Now to make this H as positive, so that like we can get an expression H is equal to, we multiply both sides with a negative 1. This gives us H is positive on the left hand side is equal to, now after multiplying with the negative 1 on the right hand side, it becomes 1 minus Vp over Vb. So 1 minus Vp over Vb, that's option A. This is the kind of rearrangement that was needed for this. I hope it's all clear. Let's go to the next question. We're given two equations, x plus y is equal to 17 and xy is equal to 72. If one solution to the system of the equations above is x comma y, what is one possible value of x? Okay, so it's quite tempting to see that we've already figured this out. You know, x times y is 72. There are just so many numbers which get 72. 36 times 2, then 12 times 6, 9 times 8. That's more like it, like 24 times 3. Okay, so what I'm trying to hint is 9 times 8 and x plus y, 9 plus 8 is 17. Okay, enough of guesswork, but let's see how to do this in like the traditional way in order to avoid any mistakes. So we need to find one possible solution for this system of equations. So I'll say y is equal to 17 minus x from the first equation, from this one. And I put this value of y in the second equation. X times 17 minus x is equal to 72. This equation becomes 17x minus x squared is equal to 72, a quadratic equation. Let's get the coefficient of x squared as positive. X squared minus 17x plus 72, bringing everything to the left hand, to the right hand side. Okay, and this becomes 0. Okay, I transferred all this to this side, then interchanged. Okay, now we need to factorize 72. As we can see, 9 times 8 would be the obvious choice. Minus 9x minus 8x plus 72 is equal to 0. X minus 9 minus 8, x minus 9 is equal to 0. X is equal to 8 comma 9. So both answers are correct. You could either mark 8 or 9 since it's a grid-in question and it has multiple correct answers. Okay, so This is how we solved this question in under 10 seconds. And this is how we solved it properly. Okay, let's go to the next one. Again, we're given two equations. X squared is equal to 6x plus y is equal to negative 6x plus 36. A solution to the given system of equations is x comma y. Which of the following is a possible value of xy? Okay, possible value of xy, not x. So it's like a multiplication of the coordinates. If either one of these is 0, the answer would be A, but let's check. So to find the solution, let's equate both the y's together. From the first equation, y is equal to x squared minus 6x. Second equation, y is equal to negative 6x plus 36. Okay, so when we equate them, add a 6x to both sides, and we see them both cancelling. So x squared is equal to 36, x is equal to plus minus 6. Okay, now it could be plus 6 or minus 6. Let's check. For plus 6, x is equal to plus 6, what would y be? In the first equation, if you put 6, it's 36 is equal to 36 plus y. Y is 0. So 1 could be 0. One possible value of this multiplication could be 0 because y is 0. If I put negative 6 in either of the two, so negative 6 becomes 36 is equal to, negative 6 would mean negative 36 plus y. Y is equal to 72. 72 times negative 6. This would be the multiplication xy, the other one. And this is going to be equal to 404, 6 to 12, 452, which is not in the options. So 36, 0. When x is equal to plus 6 and y is equal to 0, that's how we get the 0. A is the answer. Okay. Looking at the next question, be very careful what they're asking. They're asking of this product, not just x or y. Okay, even I made that mistake. Let's go to the next one. The formula above expresses the square of the speed v of a wave moving along a string in terms of tension T, mass m, and length L of the string. What is T in terms of m, v, and L? So the velocity or the speed is shown, speed of the wave is shown in terms of L, T, and m. They're asking what is T in terms of m, v, and L. Again, rearrangement of terms. So since we need to represent everything in terms of, like, represent T in terms of the other things, we'll isolate T. To do that, multiply both sides with an m. Why are we doing this? To get rid of the m in the denominator from the right hand side. This and this cancel. We're left with LT is equal to mv squared. Now we need to get rid of this L because we want to represent just T. So we'll keep just T on the left hand side. For that, we divide both sides with an L. L and L cancel. T is equal to mv square over L. That's straight up option A, which is the correct one. Okay, let's look at the next question. Y is equal to ax squared minus c. In the equation above, a and c are positive constants. How many times does the graph of the equation above intersect the graph of the equation y is equal to a plus c in the xy plane? Okay, to intersect, they must have a common, like, they must meet at a common point where the x and y would be same for both the functions. Okay, let's say they meet at x1 and y1, point x1 and y1. Let's say they intersect. How do we find that? Both the equations would be satisfied, like both this x1 comma y1 will satisfy both these equations. So y1 is equal to ax1 squared minus c, and y1 is equal to a plus c. Okay, so now if you look at the second equation, y is equal to a plus c, it does not have any x dependency. It's a straight line. Okay, it is a straight line, whereas this, the first equation, is a quadratic. So to check, let's equate. Both y1 would be same, so a plus c is equal to ax1 squared minus c. Ax1 squared is equal to a plus 2c. x1 squared is equal to 1 plus 2c over a. I divided straight away with the a on the right hand side. This is x1 squared. A and c both are positive. 1 plus 2c by a is also positive. So x1 squared, this has to be positive. The right hand side is also positive. X1 will have real roots, so which will be plus minus square root 1 plus 2c over a. So we can safely say it's going to intersect at 2 points. These are positive constants. None of them are 0. So it's 2 points. Okay. You could also see it through the graph. Okay, here's a good approach. I'm taking extra time for this question. I have a better approach than the one we solved with, although that is correct for sure. Like, that's the traditional way of doing it, the safest one. But here's a quicker way. Look at the graph. A is positive, C is positive. Y is equal to ax squared minus c. This is going to be a parabola which is opening upwards like this. Y is equal to a plus c can be any line. This value would be a plus c. Now, if the y coordinate of the vertex of this parabola lies below a plus c, is lesser than a plus c, then we can for sure say that there are 2 points of intersection. There are going to be 2 points of intersection for sure. That's guaranteed. So just check that directly. So what's the x coordinate of the vertex? Minus b by 2a. That's the x coordinate of the vertex. There is no b because no coefficient of x. That means the vertex is at 0. X is equal to 0. At x is equal to 0, what is y? Y is equal to negative c at x is equal to 0. So it's somewhere 0 comma negative c. The graph is somewhere here. So negative c is for sure lesser than a plus c. So 100% guarantee that there were 2 points of intersection. This is a quicker way, a better way to do this. Okay, 2. Let's go for the next one. This is going to be the last question of the video. So we're given 2 equations, y is equal to x squared and 2y plus 6 is equal to 2 times x plus 3. If x comma y is a solution of the system of equations above and x is greater than 0, what is the value of xy? Okay, so x comma y is a solution, x is greater than 0. So they're asking what is the value of xy. I can already guess that since they've given x greater than 0, there would be only one value of xy possible here. But let's check. So when x comma y is a solution of the system, that means it will satisfy both the equations. So we can equate the y's on both sides. So y is equal to x square is equal to 2 times x plus 3 minus 6 over 2. This is the second equation in terms of y. If you write this, 2y is equal to 2 times x plus 3 minus 6 and then divide by 2. So if I divide by 2 on the right hand side, like which is already given, this would become a 1, this would become a 3. You know why I divided directly? Because 2 is the common denominator for both the terms. Okay, so it also means 2 times x plus 3 over 2 minus 6 over 2. That's why I divided directly. So x square is equal to x plus 3 minus 3. That's what we get. So 3 minus 3 is again cancelled. Okay, it's cancelled. X square is equal to x. That means x square minus x is 0. X minus 1 is equal to 0. X is equal to 0. X is equal to 1. Since it's given greater than 0, x is equal to 1 would be the thing we'll use. If x is equal to 1, y will also be equal to 1 from this given equation. So the product is going to be 1, A. That's the answer for this. Okay. So here we conclude with the medium difficulty questions, question practice. And from the next video, we're going to do hard difficulty problems for the next 3 videos. Make sure you follow these and you understand each and every step of the solution. If not, just put it in the comments and I can take some extra time to explain to you in one of our next videos. Okay. So stay tuned, keep practicing. If you want to book any classes, you can head straight to the EudretiX website and go to the classes offered section or sign up for a group class. Thanks. Bye-bye.